Okay, fifth years. So just giving you a little bit of feedback. I've the first couple of questions done just so that I'm not writing while I'm also teaching. So firstly, define Heisenberg's uncertainty principle. Impossible to measure the position and the velocity of an electron at the same time. Then the next question you're asked, the main energy levels involved in the first line of the Balmer series. So straight away you need to know the Balmer series is my visible range, and that the visible range is my second energy level. And the red line is one you have to know, and I'd have told you this at the time, that it actually rises to energy level 3. Okay, so it goes to energy level 3 and back to 2. Okay, if there is any trouble on that, I will go over it with you when we're back in school. Distinguish between an atomic orbital. Orbital is a region of space within which there is a high probability of finding an electron. And a sublevel then is a subdivision of energy levels consisting of orbitals of equal energy. And again, most people had that. I am going to be giving individual feedback throughout the video. I know you went through energy levels there. Don't need to go into it in as much detail as that. Okay, but just that is your two definitions there. Question number 4 overall was very well answered. Okay, and this is my iron atom. And iron has an atomic number of 26. Okay, so that means I have to make enough electrons for 26. So I have 1s2, 2s2, 2p6, 3s2, 3p6, 4s, and I have 2, 4, 10, 12, 18, that's 20, so then 3d6. Okay, so that is your answer there for question 4. Okay, so next then we're asked for the electron configuration of zinc. And again, most people had this correct, which is good to see. So zinc has an atomic number of 30. So in total, I have to make 30 electrons. Again, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and that's 2, 4, 10, 12, 18, 20, 3d10. Okay, so that's zinc. Now, the next one then that we were asked, which is question number 6, and this posed a few problems. So particularly Aisling, Amy, and Caoimhe, okay? When we're talking here about chromium, chromium has an atomic number of 24. Okay, so I have 24. So I have 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s and 3d. So if I look here, 2, 4, 10, 12, 18. Now, I would usually expect it to be 4s2, 3d4. But remember, my d orbital can actually take 10 electrons, so it wants to become as stable as possible. So what happens is that this 4s only takes on 1, and this 3d takes on 5. Okay, so just to be aware of that, some of you there that I mentioned just went with 4s2, 3d4. After that then, we had question number 7. Okay, and you're asked here for a nitrogen atom, okay, and that is 7, okay. Now, Martha, I think you must have counted up, I think these wrong. I think you just put in 2p4 at the end there. Just be careful, atomic number there is 7, so there's 7 electrons in a neutral atom. Next then, we're asked for copper, and copper has 29. And again here, Aisling, Amy and Caoimhe, I think ye all did something similar to chromium. So, sorry, 1s2, 2s2, 2p6, 3s2, 3p6. Sorry, my pen has stopped working. So 3p6, 4s, and 3d again. Okay, so when we're looking at this, Okay, so again here I've 2, 4, 10, 12, 18. And again, I would expect it to be 4s2, 3d9, but that's not what happens because again, my d sublevel here can take 10 electrons, so it's more stable if it goes to 10 and it's 4s1. So again, just reminder, remember my two exceptions to my rule, copper and chromium. Okay. After that then, we had question number 9, and this is my O2 minus ion. Okay, so if I look at oxygen, oxygen in general has an oxidation number of, an atomic number of 8, which would be 1s2, 2s2, 2p6, so that's 2, 4, so 2p4. Okay, now, if I look at this, it has a 2 negative charge. My electrons are my negative charges, so I must have 2 extra electrons. So it is 1s2, 2s2, 2p6, 2 minus. Okay, and again, a couple of people got that incorrect. Okay, I think Marta there, question 9 you had trouble with. If I look then at question 10, I'm told Al3 plus. Okay, so aluminium, a neutral atom, has 13 electrons. So that's 1s2, 2s2, 2p6, 3s2, 4, 10, 2, 3p1. Okay, so that's what a neutral atom is. But if I look here, it has a 3 plus charge. So that means it has 3 more protons than electrons. That means it only actually has 10 electrons. So 1s2, 2s2, 2p6, 3 plus. Okay, and I think Quiva, that was one for you. Also Marta, another one there for you. Okay, so just be careful of that when you're asked for ions. If it's negatively, you have to add on that number of negatives because they're the electrons you have. If it's positive, it means you have 3 less of those electrons, so you need to take away those from what you have. Okay, so that's question 10. Question number 11, okay, and most people actually got this part, the oxygen, so atomic number 8, 1s2, 2s2, 2p, 2, 4, okay, so 2p4. Now, in this question you're asked, showing the arrangement of electrons in atomic orbitals. Now, we're not overly concerned here with 1s2 and 2s2, but if we were, this is what we'd be drawing. Okay, remember my electrons, they fill them singly before in pairs. That's not an issue here because the s orbital is filled. Likewise here. And when they do, you must draw them in opposite spin. Now, when you are drawing this, you have to label 2px, 2py, and 2pz. Okay, Mia, you didn't do that. You need to do that. And then Quiva, Amy, you have to show it. So I know you went into here and then you did go 2px2, 2py1, 2pz1, but that isn't showing, so you will more than likely not get your marks for that. So remember, every orbital can only take 2 electrons. You fill them singly before in pairs. So 1, 2, 3, and I have 4, and they must have opposite spin. So you have to show that to get your answer and your marks. Okay, you have to actually show that, and you have to label 2px, 2py, and 2pz. After that then, we're looking at question 12. And question 12 is state the number of sublevels and orbitals in the argon ground state. So first we have to actually write my electronic configuration really here of argon, otherwise it is going to be very difficult to do it. So I have 1s2, 2s2, 2p6, 3s2 and 3 P6. That's 2, 4, 10, 12, 18. Okay. And what you're asked for here then is you are asked for the number of sublevels. So these are my sublevels: 1, 2, 3, 4, 5. So I have 5 sublevels. And number of atomic orbitals then is a little bit different. Okay. And again, this is for probably mostly Mia, Marta. Okay. Just 5 here. Now, this P sublevel can be split into 2px, 2py, and 2pz. And likewise, this can be split into 3px, 3py, and 3pz. So what I have, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And finally then question 13. And a lot of people overall had a problem with 13. So we're looking at there Megan, Lillian, Marta, Lillian, Mia. So a lot overall had problems with question 13. So firstly, you are asked how many electrons are in 2.3 grams of Na. Okay, so firstly, what we're looking at here is I have to work out my number of moles is equal to mass in grams divided by my MR. That's 2.3 divided by 23, and that gives me 0.1 moles. Okay, I know 1 mole is equal to 6 by 10 to the 23 particles or molecules. I don't have 1 mole, I have 0.1 moles. So multiply by what I know, divide by the bit left over, and that gives me 0 by 10 to the 22 particles. And I am asked for my number of electrons in Na. So if I look, Na has an atomic number of 11, which means I have 11 electrons in a neutral atom. So 6 by 10 to the 22 multiplied by 11 gives me 6.6 by 10 to the 23 electrons. So a little bit of that is also stoichiometry.